Okay, let's dive right in, because we're talking about one of the biggest, most persistent mysteries in all of cosmology. Seriously, for decades, scientists have been staring at this puzzle. And if we solve it, well, it could completely flip our understanding of reality on its head.
And calling it a ghost in the machine isn't just for dramatic effect. It's real. When we look out into the universe, what we see, well, it just doesn't add up with our math. It's kind of like hearing a weird rattle in your car's engine. You know something's off, but for the life of you, you can't find where the noise is coming from. And we've been trying to find it for like half a century now.
So, what's the deal with this cosmic ghost? Well, here's the problem. You look at a spinning galaxy, right? You'd expect the stars way out on the edges to be moving slower than the ones in the middle, but they're not. They're whipping around just as fast. According to everything we know about gravity, those outer stars should just be flung off into deep space. But they aren't. They're sticking around. And that means some extra gravity is holding it all together.
And to try and explain this, scientists came up with an idea. They proposed this invisible stuff, a kind of cosmic glue, if you will, that's providing all this extra mass. And with it, the extra gravity to keep galaxies from tearing themselves apart. And they gave it a name you've definitely heard before: dark matter.
Yeah, so the front-runner theory for a long time was that dark matter was made of these particles called WIMPs. That stands for weakly interacting massive particles. The whole idea was that every galaxy is sitting inside this huge, invisible cloud of WIMPs, and it's the combined gravitational pull of all those particles that's keeping the stars in line.
There's just one teeny tiny problem with that. We've spent decades and billions of dollars building these incredibly sensitive detectors, deep underground, shielded from everything, all to find these WIMPs. And guess what we found? Absolutely nothing. Not a single one. Zilch. The ghost is still a ghost. And this has led to what physicists are now calling a detection crisis. Okay, but this is where it gets really interesting. What if the reason we can't find the ghost is because we're looking for the wrong thing entirely? A new theory is asking a pretty radical question. What if the problem isn't some invisible stuff hiding out in space? What if the problem is space itself?
So instead of just making up new particles to fit the data, this new idea suggests we upgrade Einstein's masterpiece, General Relativity. It basically says, hey, maybe we've been thinking about spacetime all wrong. Maybe it isn't just this boring, passive stage where everything happens.
And this is a huge shift in thinking. I mean, the standard model has always treated spacetime like it's just the background, right? Like a fixed grid that matter moves around on. But this new, enhanced model, it sees spacetime as an active, elastic medium, something that can bend and stretch and even create ripples all by itself.
And the difference here is honestly profound. See, in standard general relativity, the only thing that creates gravity is mass and energy. But in this enhanced version, the very shape, the geometry of spacetime can generate gravity. Spacetime itself becomes a player in the game, not just the game board. And the result? You don't need dark matter anymore. The need for it just vanishes.
All right, so I know what you're thinking. How does an elastic universe actually work? How does spacetime being stretchy and active solve the whole spinning galaxy problem? Where does that missing gravity come from?
Well, it all starts by tweaking Einstein's famous equations. Scientists add something called extra tensor fields. Now, that sounds complicated, but in simple terms, it's just a mathematical trick to give the shape of space its own energy. Suddenly, geometry isn't just a result of matter being present, it becomes an active source of gravity all on its own.
The best way to think about it is like a guitar string. These extra tensor fields add tension to the fabric of spacetime. And with that tension, the fabric can hold specific shapes. You could call them wrinkles or bends. And because spacetime is now elastic, these shapes don't just stay put. They travel, they propagate as self-sustaining waves, just like when you pluck a guitar string and the vibration travels down its length.
And this completely changes how we think about what's happening in a galaxy. The old dark matter idea was a pull theory, right? You've got this invisible mass pulling on the stars, yanking them around. But this new model, it's a flow theory. The stars aren't being pulled, they're being carried along by waves in space-time itself. They're literally surfing the geometry of the universe.
So what this really means is that spacetime is the medium. It's the whole show. The gravitational effects we see aren't coming from particles. They're just a natural feature of spacetime's own geometry. It's that internal tension in the cosmic fabric that lets these waves travel.
And as they travel, they shape the galaxies we see. And boom, just like that, the whole dark matter mystery kind of just evaporates. There's no missing particle we need to find anymore. The extra gravity we've been trying to explain for decades, it's not coming from some phantom stuff. It's coming from the dynamic, waving, flowing geometry of space itself.
So, that ghost in the machine? The one we've been hunting for all this time? Turns out, it wasn't some intruder hiding in the cosmic engine room. It was the engine room. It was the hum and the vibration of the machine itself. The extra gravity we were looking for wasn't a missing ingredient. It was just a behavior of the universe we hadn't understood yet.
You know, this new perspective, it does more than just solve a nagging problem. It gives us a universe that's way more elegant, way more vibrant. It suggests that maybe we should stop looking for things hidden in space and start paying more attention to the beautiful, complex dance of space itself. And really, what a profound thought that is.